all those other things you did were really nice, but at the end of the day, your one job was... I can't count the number of times I've had those conversations with my kids. They'll send them on a mission to do a job, they'll come back and they'll have done all kinds of other stuff, but miss the one thing that they were supposed to do. And that's why in this nugget, we're going to discover the methods switches use to learn MAC addresses, that's their one job, and how quickly they can forget them. You're going to find as you step deeper into switches, they do a ton of things, but their core function is to really figure out all of the layer 2 addresses that exist on their network, we call them MAC addresses, and put them into a database and move data between them. So we're going to start off in the land of Arizona. That's this topology right here, where people are making some fires, living with cactuses, and the switch network is all connected together in the back. This is the logical diagram of that network. Now I have my computer directly plugged in right here into one of the ports on this switch. So let's connect a console cable right here to this device and find out where I am. I'll bring that connection up, hit the enter key a couple times, and get logged in. Now the key command that exposes that core function of the switch is the command show MAC address table. Now, over the years, Cisco has represented it a couple different ways. One is show MAC dash address dash table. Another is show MAC space address dash table. Best bet for you is to use the question mark to figure out what version of the command you're going to get on the switch iOS that you're using. So I'm going to type in show MAC question mark, and you can see I hit question mark right after MAC. If the command was show MAC dash address dash table, I would see that right here. But in this case, it just says the only command I've got is MAC. So I'll do a space question mark, and there I've got the address table. Right click on that, paste it in, hit the question mark, and you can see all kinds of flexibility that I can use with this command. If I want to expose a specific interface, like I just want to see MAC addresses on that one interface, great. If I want to see MAC addresses that are all starting with a certain letter or ending with a certain letter, great. I can do all of that. And actually, I'm going to create a second nugget where I show all the ways to filter the MAC address output, because it's something you do all the time in the real world and something you've got to get really proficient at to do well in a switch network environment. So let's go back here. I'm just going to hit the enter key on show MAC address table. And the first thing that you see is a whole bunch of static MAC addresses. What? What are these things? And if I look at the port, it says this is assigned to the CPU. In reality, this switch is using all these MAC addresses for itself. That is, when Cisco created this switch, which this is actually the Cisco 3550, they said, we're going to use this pool of addresses so that if it needs different MAC addresses, it can use these. In newer switches, they actually hide a lot of those MAC addresses so you don't see them, because they found it caused a lot of confusion. In our case, you can just ignore all of those. We don't really care about the ones assigned to the CPU. We just know those are behind the scenes. So then right here, I see all the MAC addresses that this guy has learned dynamically. It's the dynamic ones that we care about, because these are the ones that it has learned by itself. Notice what interface it learned them on. I see this MAC address on Fast Ethernet 0/2. This MAC address also on Fast Ethernet 0/2. Okay, well, hang on a second. If we've got a switch and it's got Fast Ethernet 0/2 plugged into something, how could that something have two MAC addresses? Well, the answer is that something is probably another switch. Remember, in our network environments, we have these connections, which are typically called uplinks, which connect our switch to other switches in the network. We just happen to be sitting on this switch right here, connected to the console port, and doing a show MAC address table. I see two MAC addresses that it's learned going out this interface. I also saw, if I remember right, one MAC address that's going out this interface connected to the wireless access point. If I go back there, I can see that guy as well. But here's the interesting thing. I don't see my computer. No. I'm not talking about my computer connected to the console port. Come take a look over here. This is the Arizona switch stack, and I can see my computer is plugged into the console cable right here on the back. Now, the console cable is not a network connection. It's a serial connection, so it does not count in any way, shape, or form to learn MAC addresses. There are no MAC addresses on this cable. What I'm talking about is this cable. This cable, if I were to trace it, actually runs to the network card on my computer, and I can see, just because I can see the front of this display, this is plugged into port 13. That's what's blinking right here. But if I go back here and do that show MAC address table, I I don't see it. I see Fast Ethernet 02, 02, 03. Why doesn't it see my computer on Fast Ethernet 0/13? Well, the answer is it's actually being quiet. If my computer has nothing to say, it's not going to speak anything out the network card. Remember, the only way a switch learns about an attached device is if it sees packets going in or coming out of that source MAC address. So as soon as my computer transmits, it looks at the header information and goes, oh, I know who you are, and adds it to the MAC address table. But it only does that for a certain amount of time. Watch this. I'm going to open a command prompt on my computer and do a ping 192.168.1.2. Hit the enter key, and sure enough, I'm getting a response. That should be enough to generate some network traffic. I'm going to do a show Windows command prompts, but I can do an ipconfig/all because I want you guys to see my MAC address right here. This is my Dell DocNIC, and right there, just remember 9C1A. The first two and the last two will usually be enough to be unique. I'm going to come back here and do a show MAC address table again, and now you can see that on Fast Ethernet 0/13, that MAC address is showing up. I want you to see something else that's interesting. I'm going to do that same show MAC address table command and hit the question mark, and look at this right here, aging time. Now I can change this, but I want you to see the default. When I hit enter, it comes up and says, hey, the global aging time is 300. 300 what? 300 seconds. That's 5 minutes. So if my computer is quiet again, meaning I don't ping anything, I don't access anything for 5 minutes, it's going to remove that MAC address out of the table and have to relearn it again. Okay, so hang on, concept checked. We know that my computer is plugged into Fast Ethernet 0/13, right? We know that it has a MAC address. I don't remember what it is, right? But we know that that switch will remember it for 300 seconds before it automatically forgets it because of that default aging time. That's our 5 minutes. So my question is, what if there's another computer right here, and let's say it's 303 seconds later. The switch has forgotten my MAC address. It doesn't know where I am. And this computer sends a ping message over to my MAC address. So let's just call this computer A. It's sending a ping message destined for computer A. That switch gets it. What does it do? Do you remember? What does it do? So the answer is it floods it. That's known as MAC address flooding, meaning as soon as it receives that message and it doesn't know where it is, it will flood it. It treats it just like a broadcast message, meaning it will send it out every single port except the port that it received it on in hopes that it can contact that device. Now, the device will get the message because it'll receive it. It'll be one of the ports, and it will reply. And as soon as it replies, the switch adds it to its MAC address table. This happens every single time you reboot the switch. That's a common instance when, not rebooting switches, that rarely happens, but when you do, it will completely forget the MAC address table, and probably within 1 minute, I'd say 60 seconds, it's got all of the MAC addresses that are commonly in use automatically rebuilt, but during that time, there's a lot of flooding going on because it hasn't learned where all those MAC addresses are. At any time on a switch, you can type in clear MAC address table, and it will actually, let me add the command on there, dynamic, enter, and it will automatically clear all the dynamic addresses out and relearn them. So if you want to cause a mini network flood, and that's not a scary thing, but it will cause a lot of network traffic for a brief instant while everything's relearned, you can just clear the MAC address table on your switch. This is useful when a MAC address gets stuck in there. I've seen that happen when people are doing IP address changes on the network and the IP address and the MAC address don't quite align yet. At that time, it may make sense to clear the MAC address table on your switch. One other thing I just want to plant the seed on. When we did the show MAC address table on this switch right here, we saw that it had MAC addresses on here, on here. We even saw the MAC address on Fast Ethernet 0/13, which was going to my computer up here. Which port didn't have any MAC addresses? That guy's mysteriously missing. Now that's really odd because I'm looking there and it looks like that guy has a connection up to the other core switch. I would think that that would have at least one MAC address, right? The MAC address of the core switch. Why do you think that doesn't have any MAC addresses? I'll give you a hint. And this is my sneak peek at an up and coming concept. It's not going to be in this skill, but it will be soon. It is the idea of spanning tree protocol. And I'm going to plant the seed now because it's as good a time as any. I'm going to type in the command show spanning tree. And spanning tree is letting us know that fast Ethernet 0/1 is actually blocked. Blocked? Blocked? What? Like disabled? Yeah, disabled. Totally cut off. Why would it do that? Because if it didn't, the entire network would go down in flames. Spanning tree protocol is a loop prevention mechanism. You'll see it written all the time, STP, really hard to see in yellow, so I'll flip on over here to a nice fuchsia. STP. Is that fuchsia? I'm not good with colors. If all these interfaces are active and a broadcast message gets sent, it will get sent out all interfaces. Let's just say my computer right here sends a DHCP request, which is a broadcast. This switch would send it out all interfaces, right? It'd be received by these two switches. These switches would send it out all interfaces. And then they would receive the broadcast going the other way and send it out all interfaces and send it back to this. So you get the idea, right? You're going to end up with this round and round and round and round. Actually, it takes down the entire network. A broadcast storm is what that's called, and it caused complete annihilation because of the default flooding behavior of switches. So what Spanning Tree does is it comes in and blocks a port. It recognizes loops in the network, identifies what the lowest priority port in the network is. Now, how it figures all that out is a whole topic for the spanning tree skill. But that's what you'll see in a lot of cases is ports that you think should be sending traffic actually won't, because spanning tree is doing a good thing and preventing a loop from happening inside of our network. The good news is spanning tree is always watching. The eyes of Spanning Tree are everywhere. And if it sees this connection goes down, it will automatically unblock that link so you still have the resiliency in your network that you're hoping for. More on Spanning Tree in another episode. For now, we've seen how switches learn MAC addresses and how quickly they forget. 5 minutes, right? I hope this has been informative for you, and I'd like to thank you for viewing.